Hello friends, today we are going to discuss about the concept of continuous probability distribution. In the previous class we discussed about two probability distributions, binomial and Poisson's distribution. Both are discrete probability distributions in which variate can take only integer values, where variate can take only integer values. In this section now we are going to discuss about continuous probability distributions. In which a random variable takes non-countable infinite number of values. Means what? That is, variate can take the values in the interval. Any value in the interval means what? Both binomial and Poisson's distributions, variate can take only integer value. In this continuous probability distribution, variate may take any value in the given interval. So in this there are mainly two types of continuous probability distributions. You are going to study now. One is exponential distribution and the other one is normal distribution. So we are going to study first exponential distribution. So first one, exponential distribution. So definition: the continuous probability distribution having the probability density function f of x, probability density function, that is we call as a PDF. F of x is given by f of x is equal to, it is alpha into e raised to minus alpha x for x greater than 0. It is 0 otherwise. Function takes the value as alpha into e raised to minus alpha x for x greater than 0, otherwise it is 0, where alpha is greater than 0, is known as the exponential distribution. So integral from minus infinity to plus infinity f of x dx, we write it as infinity minus infinity to 0 f of x dx plus 0 to plus infinity f of x dx. We can write like this. So minus infinity to 0, according to function it is 0, plus it is 0 to infinity, function will be alpha into e raised to minus alpha x dx. So this is alpha into e raised to minus alpha x all divided by minus alpha, limits varies from 0 to infinity. So this gives minus 0 minus 1 equal to 1. So this implies integration from minus infinity to infinity f of x dx is equal to 1. Also f of x greater than 0. So f of x satisfy both the condition for a continuous probability distribution. That is we call this as a continuous probability function. It satisfies both the condition. Now we find mean and standard deviation for this distribution. So mean and standard deviation for exponential distribution. First one, mean mu. For VTU syllabus, we don't have any derivation for this mean and standard deviation. So function is minus infinity to infinity f of x dx is your probability function. So this is equal to minus infinity to infinity x into alpha into e raised to minus alpha x dx. So this gives us alpha into 0 to infinity x into e raised to minus alpha x dx. So applying, using Bernoulli's rule for integration, you will get using Bernoulli's rule for integration, by parts, we have mean mu is equal to 1 by alpha. Next, variance. Is sigma square. It is minus infinity to infinity x minus mu whole square into f of x dx. So this is, we will substitute the values. So it is alpha into 0 to integration 0 to infinity x minus mu whole square e raised to minus alpha x into dx. Same, applying Bernoulli's rule, we get sigma square as 1 by alpha square. So this is nothing but sigma is equal to 1 by alpha. Thus standard deviation ST is equal to sigma, that is equal to, so standard deviation is also 1 by alpha. So means what? Hence for the exponential distribution, mean mu is 1 by alpha and standard deviation sigma is equal to 1 by alpha. So we observe that mean and standard deviation are equal to the exponential distribution. So now we'll solve some examples.